children, warmly welcome to Guru Gedara educational program. Today also I am going to teach you another important lesson in grade 6 science syllabus which comes under unit 8 electricity for a comfortable life. My dear children, as you can remember, in the previous lesson we studied about the beginning of that unit, electricity for a comfortable life. In that lesson, you studied about how to generate electricity, the applications of electricity for our day-to-day tasks, those things. Today, we are going to study how to prepare circuits by using electricity. My dear children, today, to study about this lesson, I am going to do a little activity. Let's focus our attention on this activity. What is the activity? I am going to ask you a question. What is meant by a circuit? Do you know? Right. What is called as a circuit? Let's do a simple activity to find out what is called as a circuit. First of all, I am going to do a little activity. In this activity, I am going to light up a bulb. To light up this bulb, I am going to use certain materials. Here, my dear children, you can see I am going to use a bulb. I want to light up this bulb. So, I use a bulb, a connecting wires, a dry cell, and also a switch. Let's try to light up this bulb using these components. Right. First of all, I am going to connect this bulb to the dry cell and then the connecting wires to the switch. You can observe. And then the other end of the connecting wire to the negative terminal of the dry cell. Now, my dear children, I have prepared a simple structure. Now, I am going to switch on the switch. What can you observe? The bulb is glowing. I am going to switch off. The bulb goes out. Right. Again, switch on. Then, you can observe the components here. You can see a bulb, a dry cell, connecting wires, and a switch. How do we call for such kind of setup? My dear children, this is called as a circuit. This is a very small and simple circuit that we can prepare by using these components. Right, my dear children? This is the system that we arrange. You can watch it. This consists of a bulb, a switch, connecting wires, and a dry cell. This is called as a circuit. Then, let's learn how to define the term circuit. What is that? You can build up a definition. Right. A system which allows to flow an electric current through it is called as a circuit. How do you call? A system which allows electricity to flow through it is known as a circuit. Today you learn about how to prepare a circuit and what is the definition for a circuit. Right. Now, my dear children, you can understand that when arranging these circuits, we have to use various accessories. We used connecting wires, a bulb, a dry cell, a switch. How do we call for these accessories that we use when making circuits? Those are called as electrical accessories or electrical appliances. Now, let's focus on these appliances that we use in our day-to-day life to prepare circuits. Right. Here you can understand the meaning again. The accessories used to prepare the circuits are known as electrical appliances. Hello children, let's focus our attention on some of the electrical accessories that we use in our laboratory to prepare circuits. I think you can remember some of the accessories that we used in the previous circuit. In the previous circuit we used a dry cell, a connecting wire, a bulb and a switch. Now I am going to teach you some other electrical accessories that we use in our laboratory to prepare circuits. You can study one by one. Okay? Right. First of all, we can study all the accessories that we are going to discuss here. First of all, dry cell. You can remember what is the dry cell. In the previous lesson also you studied about dry cell. Second one, connecting wires. Connecting wires. Third one, switch. We have to use switches when making circuits. Then we can study about bulbs. You all know there are various types of bulbs. Next one, ammeter, milliammeter, galvanometer and voltmeter. Right, my dear children, when preparing circuits, we should have a sound knowledge about these accessories. We have to use them very carefully. Right, let's learn from the beginning. First one of electrical appliances that we used in our laboratory. Let's learn more information about these appliances. Right, my dear children, you can watch a dry cell. I am sure you can remember what is dry cell. Can you remember? In the previous lesson, when we study about methods of generation of electricity, we learned that electricity can be generated by using a chemical cell. Then this dry cell comes under the chemical cell. We know that we use various types of dry cells in our day-to-day life. I am going to show you some of the examples. This is a dry cell that we use in our school laboratory to prepare circuits. This is also another dry cell. This consists of two dry cells. Right. My dear children, can you remember a dry cell consists of two terminals? What are they? Each and every dry cell consists of a positive terminal and also a negative terminal. You can watch. Before moving to that part, I am going to ask you a question. What is the purpose of this dry cell? Why do we use a dry cell in this circuit? Do you know? As shown in this picture, you can watch that the main purpose of dry cell is obtaining current or obtaining electricity for the circuit. We can say dry cells are used to supply electricity for the circuit. Then you can watch the main parts of the dry cell. The dry cell consists of a positive terminal and also a negative terminal. You have seen the metal cap is at the positive terminal, negative terminal is at the other side. Now, let's focus our attention on the connecting wires. What are called as connecting wires? You can remember, when preparing a circuit, we have to connect the appliances that we used in the circuit, because we use dry cells, bulbs, switches. So how can we connect these appliances? In order to connect these appliances, we have to use connecting wires. Have you seen connecting wires? Yes, you may have seen. Today I brought some of the connecting wires to show you. There are different types of connecting wires, different colors, different sizes. Right, you can watch. These are some examples for connecting wires. Some are yellow in color, some are brown in color, some are blue in color, some are green in color. These wires have the same thickness. The diameter is same, thickness is same. But you know, my dear children, when you think about some advanced circuits, we have to use connecting wires of different sizes, larger diameter, right? Then I am going to ask you a question again. What's the purpose of using these connecting wires? The main purpose of connecting wires is to connect the appliances that we use in the circuit. So we can say connecting wires are used to conduct electricity for different parts in the circuit. Right, you can remember. Let's watch a picture of connecting wires. As I told you earlier, you can watch. Connecting wires differ from size and color. There are different colors. Then we have to focus our attention on the structure of the connecting wire. You might have seen, we can see only the external part of the connecting wire. It may be blue color, black color, yellow color, or another different color. But when we draw our attention on the structure of the connecting wire, my dear children, you can understand it very clearly. As shown in this picture, connecting wires consist of a wire, a metal wire, and also a rubber outer covering. Now, what do you think about the reason? What's the purpose of having a rubber outer covering around this connecting wire? Because you know, though we use electricity for our day-to-day activities as well as for making circuits, we have to use it very carefully, because if there is an electric leakage, there may be accidents. So we have to take precautions before using the electricity. Right, that is what the connecting wires are covered by rubber wire. Then switch. I am going to show you switches used in circuits. This is a very simple switch. You can watch this very carefully. And also, I am going to show you another switch that we use in our laboratory. Right? You can watch this very carefully. My dear children, this is called as a tap switch. Why is that? By tapping on this knob, we can disconnect or connect. Okay? Right. Now I am going to ask you another question. Why do we use switches when preparing circuits? Think about, why do we use switches? We use switches to connect or disconnect the supply when and where necessary, because sometimes we want to supply the electricity for the circuit. Some other times we want to disconnect the supply. This is done by using a switch. There are various sizes of switches in our school laboratory. Right. Let's move to the picture which shows you different types of switches that we use in our school laboratory. Right. You can watch. There are different sizes, different colors and different shapes. Now, this is the circuit we prepare at the beginning of the lesson. Here you can watch. The first picture shows you an open switch. You can understand, when disconnecting the switch, electricity does not flow through the circuit, bulb does not glow, because this is an example for an open switch. Let's move to the second picture. This is a closed switch. The switch is properly connected, so electricity flows through the circuit, the bulb glows. Then you can understand the main purpose of using a switch in a particular circuit. Switches are used to connect or disconnect the supply when and where necessary. Dear children, do you know the use of these bulbs? Right. Bulbs are used to obtain light and also to identify whether current flows through a circuit. Why do I say so? When using a bulb in a simple circuit, if the bulb doesn't glow, we can understand that there is no flow of current. But when the bulb glows, we can understand, we can identify that current flows through the circuit. Now I will show you it again. You can watch that here. I am going to prepare the previous circuit again to understand the use of bulb. Now here, what can you understand that? Current does not flow through the circuit because bulb does not glow. Now what happens? Glowing of bulb gives an idea flowing of current through the circuit. As I told you, we use bulbs to obtain light and also to identify whether the current flows through the circuit. This is what we use a bulb. Let's focus our attention on different types of bulbs. You can watch. You have seen these bulbs in the market. Right. Another important accessory that we use in our school laboratory is the ammeter. Do you know what is called as ammeter? Have you ever seen an ammeter? I am going to show you an ammeter. Right. This is the ammeter. You can watch. Ammeter consists of positive terminal, negative terminal, a scale, and also an indicator. Do you know the parts of an ammeter? Dear children, we have to identify the difference between ammeter and milliammeter. As I told you earlier, ammeter is used to measure current, but milliammeter is used to measure very small amount of current. Then when you look at the picture of a milliammeter, you can watch that it is mentioned as simple M, capital A, milliammeter, simple M, capital A. But in the ammeter, only the capital A is there, right? But in the ammeter, it shows as capital A, right? In the previous program also, I showed you a galvanometer. But today also, I am going to show you a galvanometer, and I am going to explain you the use of galvanometer. This is the galvanometer. You can watch that galvanometer shows you the letter capital G. In the ammeter, capital A. Milliammeter, simple M, capital A. This is how we identify the difference between the ammeter, galvanometer, and the milliammeter. Now, what's the use of this galvanometer? As you can watch, galvanometer is used to identify a very small amount of current. A very small amount of current, to identify a very small amount of current. Then I am going to show you a simple activity to find out the use of galvanometer. Right, my dear children, as you can remember, in the previous program we studied electricity can be generated by using a dynamo. You can remember, my dear children, electricity is generated in the dynamo by using a coil and a magnet. Here there is a coil and also a magnet. I am going to connect this dynamo to the center zero galvanometer using connecting wires, and then you can watch how to identify electricity using the center zero galvanometer. Right. Watch very carefully. I am going to connect positive terminal to the positive side, negative terminal to the negative side of the galvanometer. Right here. You can watch, my dear children, when I am going to rotate this dynamo in clockwise direction, the galvanometer indicator shows a deflection to the right side. First of all, you can watch this. Can you watch? Right. Now I am going to rotate this dynamo wheel towards left side, anti-clockwise. Then you can watch the galvanometer indicator shows a deflection to the left side. Then you can understand that the galvanometer is used to identify a very small amount of current, because the deflection of the indicator shows you the flow of current. Not only that, a galvanometer can be used to identify that the direction of flow of current. Now I am going to rotate this wheel in both directions. Now you can see that the deflection of the galvanometer takes place in both sides. That is the directions of flowing of current. Right. I think you can understand the use of galvanometer. The galvanometer is used to identify a very small amount of current. Right, my dear children, today we studied about how to prepare a circuit and what are the electrical accessories that we use in circuits. I am sure you have a good idea about these accessories and how to prepare a circuit. Now, I am going to focus your attention again on the previous circuit. Now here, look at this circuit, my dear children. Here, the circuit consists of, as you know, a bulb, connecting wires, dry cells, a switch. Now, sometimes in your school, you may ask, please draw this circuit. Is it possible to draw this circuit on your notebooks? It's very difficult. It is very difficult and it takes a lot of time to draw the electric circuits using pictures. Here you have to draw the bulbs, dry cells, switches, wires. It takes a lot of time and it is hard to draw. Is there any solution for this? How can we draw these circuits easily? Now, I am going to teach you another important method of drawing circuits on your notebooks. You can watch. We have to use symbols. My dear children, you have seen symbols. When you travel on the road, you have seen various symbols, road symbols. My dear children, when we go to a hospital, you have seen the symbol of the hospital. It is a red cross. By looking at this red cross symbol, you can understand that there is a hospital. Likewise, in our day-to-day life, we use various symbols. Why is that? When using symbols, anyone can understand the meaning of a particular description without having the ability to read letters. Elders or the people with poor literacy, they can understand the symbol. It is easy to read that. As a result, when preparing these circuits, we have to use symbols. We can use these symbols to draw the circuit diagrams on your notebooks. Using symbols for electric appliances in circuits. Right, my dear children. Let's learn the symbol of the electrical appliances that we learned earlier. We learned several electrical appliances. You can watch the symbols relevant to these appliances. This picture shows you a bulb. What is the symbol that we use for the bulb? This shows you the symbol of the electric bulb. For dry cell, without drawing a dry cell, we can just draw this symbol. This symbol consists of a longer line and a shorter line. The longer line represents the positive terminal of the dry cell. The smaller line represents the negative terminal of the dry cell. So, this is how we represent the symbol of the dry cell. Let's move to the battery. Can you remember the difference between a cell and a battery? I told you earlier. A cell is a single cell. A battery consists of two or more cells. Here you can watch two dry cells are connected. When two dry cells are there, this is called as a battery. Then symbol of the battery can be represented in this way: positive terminal, negative terminal, short line, positive terminal, negative terminal. This is the symbol of a battery. A battery means two or more cells. Now, you know, we use connecting wires as very important electrical accessory. So, symbol of the connecting wire is a short line, a straight line. The straight line can be used as the symbol of connecting wires. Switches. There are two symbols for a switch. What's the difference between these two? As you can watch, this symbol represents the open switch when the power is disconnected. This symbol represents the closed switch. In this case, electricity passes through the circuit. In this case, no current passes through the circuit. Ammeter. You watched a picture of ammeter. Here, the symbol of ammeter is given. Inside the circle, we have to use the capital A. This is the symbol of a galvanometer. Inside the circle, capital G is written. Now, circuit diagrams using symbols. Now, we all studied the symbols of electrical accessories. Then you will be able to draw the circuit diagrams using the studied symbols. I am going to give you a simple task. What is that? You have to draw the circuit diagram of the circuit given in this picture. This consists of a bulb, connecting wire, a dry cell, and a switch. Try to draw the circuit diagram. Right. I am sure you all have drawn. It's very simple. Your circuit diagram should be like this. This is the symbol of the bulb. The black lines are used to represent connecting wires. This is the open switch. This is the symbol of a dry cell, long terminal, short terminal. The long line represents the positive terminal and the short line represents the negative terminal of the dry cell. This is the circuit diagram of the circuit shown in the left side. Now, let's do a simple activity. Try to make two different circuits using two bulbs, a dry cell, a switch, and connecting wires. My dear children, I have arranged two circuits in different manner. Can you note the difference between these two circuits? Yes, you can identify the difference here. In the first circuit, I have used two bulbs in the same line, one bulb after the other, and a switch, connecting wire, battery. This is the first circuit. Now you can watch the picture of the circuit I arranged here. Here, battery, switch, two bulbs in the same line. Now let's focus the attention on second circuit I arranged. Here two bulbs are placed parallel to each other, and then switch and the battery. Now you can note down the difference between the two circuits. This is like this. Two bulbs are placed parallel to each other, switch and the battery. I am going to light up both the bulbs. You can watch them. First one, you can watch that. When tapping the switch, current passes through the circuit, bulb glow. Second circuit, current passes through the circuit, bulb glow. Right. Now I am going to give you another activity. The two circuits are given. You have to draw the circuit diagrams for each circuit. Try to do it. Draw the circuit diagram for this circuit, where we keep two bulbs in the same line. It will be like this. You can watch. Cell, switch, bulbs one after the other in the same line. Let's draw the circuit diagram for the second circuit. Two bulbs parallel to each other. It will be like this. Cell, switch, bulbs parallel to each other. Now my dear children, when you think about the simple circuit, you should understand the flow of current. Do you know? A dry cell consists of two terminals, negative terminal and positive terminal. Electricity flows from positive terminal to the negative terminal. So electrons inside that flow from negative terminal to the positive terminal. You have to keep in mind the direction of flow of current is positive terminal to the negative terminal. Right. Now let's learn how to connect an ammeter to a circuit. As you studied earlier, you can remember ammeter consists of a negative terminal and a positive terminal. So when connecting that, we must consider about the terminals. How do we connect? I will show you how to connect an ammeter to the circuit. This is the ammeter. If we want to connect the ammeter to this circuit, we have to connect the red colored positive terminal to the positive side of the battery or dry cell. Here, red colored one to the red positive side, and then the black colored terminal of the ammeter to the negative side. Now you can watch, when tapping the circuit, bulb glows. That is due to the flow of current. At the same time, you can watch the little deflection in the indicator. Can you watch? When supplying the current, a deflection of the indicator takes place. That is how we connect an ammeter to a circuit. The terminals of cells and batteries are named as positive and negative. Current always flows from the positive terminal to the negative terminal. When fixing an ammeter to a circuit, the positive terminal of the ammeter should be fixed to the positive terminal of the battery or cell. Right. Then I am going to give you another activity. Please try to answer for this question. Do you know the symbols of these electrical appliances? Dry cell. You can remember. This is symbol of the dry cell. Open switch. ammeter. Right. Symbol of the bulb. Right. Symbol of the closed switch, like this. Then I think you studied the symbols of electrical appliances properly. Let's move to the next lesson. It is conductors and insulators. Do you know what are called as conductors, what are called as insulators? Let's move to a simple activity to find out the difference between conductors and insulators. We can arrange this simple circuit: a bulb, a dry cell, and a gap called in between A and B. Right, this is the batteries they are. I have used two dry cells, a bulb, connecting wires, and this is the gap A and B. I am going to keep copper. You know, my dear children, this is called the metal copper that we used in the laboratory. I am going to place this copper piece in between A and B. You can watch whether the bulb glows or not. What can you observe? Bulb glows when keeping copper. What does that mean? Current passes through the copper. Now I am going to keep a piece of polythene here. This is a piece of polythene. I am going to keep this piece of polythene between A and B. What can you observe? Does the bulb glow? No. There is no glow of the bulb. That means current does not flow through the circuit. Then I am going to keep a piece of aluminium. This is the aluminium metal we use in the laboratory. I am going to keep this aluminium. What can you observe? Bulb glows. That means aluminium is a conductor. I am going to keep an eraser made up of rubber in between A and B. Bulb does not glow. That means current does not pass through the rubber. Then I am going to keep a piece of magnesium. This is the magnesium metal in the laboratory, and check whether current passes through the magnesium. Now you can watch bulb glows. That means current passes through the magnesium. Now I am going to keep a piece of paper, just a piece of paper. Bulb does not glow. That means current does not pass through the papers. Now I am going to keep another metal in the laboratory, lead. Bulb glows. That means current passes through the lead. This is zinc. I am going to keep a piece of zinc. Current passes, bulb glows. That means, my dear children, from this simple activity, you can understand that when keeping different materials between A and B, sometimes bulb glows, sometimes bulb did not glow. That means the main reason is if the current passes through a particular material, bulb glows. If the current does not pass through a particular material, bulb does not glow. So that we can say that materials which carry electricity and materials which do not carry electricity, if the electricity passes, bulb glows. Electricity does not pass, bulb does not glow. What are the materials? Aluminium, copper, iron, brass. Brass is also an alloy. Zinc. These materials conduct electricity. Wood, rubber, paper, glass, rigiform, they are called as the materials which do not conduct electricity. Right, my dear children, then we can classify the materials in this world into two groups. How? Materials that conduct electricity are known as conductors, while materials that do not conduct electricity are known as insulators. Here we have to study that as electrical conductors, electrical insulators. Right. Now I am going to ask you a question. Are there any liquids that conduct electricity? What do you think about? Earlier we studied that most of the metals, aluminium, copper, zinc, they conduct electricity. But all they are solids. What do you think about liquids? Are there any liquids that conduct electricity? What's the answer? Yes, there are liquids that conduct electricity. What are the examples? What are the examples? You know, mercury, it is a liquid metal, salt solution, water, they are the liquids or solutions that conduct electricity. My dear children, we have studied how to prepare circuits, what are conductors, what are insulators. Now this is the final part of our program. I am going to ask you some questions before wind up this session. Right. Select the correct answer from the brackets. Blank is an insulator. Water or plastic? What's the answer? Plastic is an insulator. It does not conduct electricity. Question number 2. Outer casing of connecting wires are made up of blank, aluminium or rubber. You can remember, we studied that. Outer casing of connecting wires are made up of rubber. Question number 3. It is dangerous to touch electrical appliances with blank hands. Wet or dry? What do you think about? Is it okay to touch the electrical appliances with wet hands? Let's see the answer. It is dangerous to touch electrical appliances with wet hands. Why is that? Wet hands means there is water. We learned earlier, even though the water is a liquid, it conducts electricity. So don't touch, keep in mind, don't touch electrical appliances with your wet hand. Alright children, today I am going to give you some homework. You can prepare these simple circuits at home with the help of your parents and try to understand how electricity passes through the circuits and how switch works and the different types of circuits by using 2 bulbs, by using 3 bulbs. Right. You can enjoy by doing these activities at home. Right. Then I am going to wind up this session. Before that, let's move to the summary. Right. What did we learn today? Today we studied about a circuit. What is a circuit? You can remember, a circuit is a system which allows the electricity to flow through it. Then we learn how to prepare circuits. We prepare several circuits. Then we learn electrical appliances that we use to prepare circuits. Bulbs, batteries, dry cells, ammeter, galvanometer. We learn all those things. After that we learn about preparation of different types of circuits. Then we learn symbols of circuit appliances. After that we learn how to draw circuit diagrams using those symbols. Then finally we learn conductors and insulators. What are conductors? Conductors are the materials that allows the electricity to flow through them. Insulators are the materials which do not allow the electricity to flow through them. Alright, I hope you enjoyed the lesson. For more information, refer to the textbook, answer past paper questions and also engage in these activities. You can watch this lesson again through channel NIE YouTube. Have a nice day.